Okay, folks, so here's problem 4 in the week 1 homework assignments on statics and strength of the materials for construction. You'll see here this is a pyramid, and you need to read carefully the description of this. I worked through this problem and did lengthy calculations. I made it much more complex than I needed to be the first time I worked through it, because one of the operative words here is that it has symmetrical sloping faces. So what they're asking you to find is, what is the slant height? In other words, the distance. And you have to kind of conceive of this pyramid as having a smooth surface all the way from one apex to the next. They're asking what is the length of that, as well as what is the length, of the width down here. That's what you're trying to calculate. Now, like I said, the fact that it's symmetrical is operative in this. If you take away this constraint that this be a symmetrical triangle, the problem becomes much, much more complex. So we want to draw this in as a symmetrical triangle. Well, if it's symmetrical, what that means is that whatever this angle is over here, and maybe we call this angle A, has to be equal to this angle B. And so we'll call this angle here at the apex up here, we'll call this angle C. These are all lowercase, which would mean that this base here is side C, which is uppercase. This would be side A, capital A. The sides are named after the angle that they are opposite to, and that would make this side over here side capital B. And the assumption that this is symmetrical tells us then that A equals B, and it tells us that length A equals length B. Now, if we think about trying to calculate angle A, well, angle A is a component. It has a complement, which is 42 degrees 8 minutes. So we know that angle A equals 90 degrees 0 minutes minus 42 degrees 8 minutes. The problem is you have to do borrowing here. You can't subtract 8 from 0. So this is just like when you learned subtraction, probably in first grade. You have to borrow. Well, that means I got to take 1 degree away, so I'm going to make this 89 degrees. And then how many minutes is that? Well, 1 degree is 60 minutes. So 89 degrees, 60 minutes. And I'm going to subtract from it 42 degrees, 8 minutes. So 60 minus 8, that's 52 minutes. 89 minus 42, well, let's see, if it was 89 minus 50, that'd be 39, and then 42 is another 8, so 47 degrees. So 47 plus 42 gives you 89. Yep, that works out. So angle A is 47 degrees 52 minutes, just by the property that complementary angles add to 90 degrees. So 42 degrees I'm sorry, 47 degrees 52 minutes. And by the property that this is a symmetrical triangle, and this is going to be the same, 47 degrees 52 minutes. Well, angle C we can figure out just by the supplementary angle rule, namely that A plus B plus C need to add to 180. So again, we can try and calculate this over here. So we'll start with 180 degrees, 0 minutes, minus 47 degrees, 52 minutes, and 47 degrees, 52 minutes. That will give us the value of angle C. Now the problem is, if you look at this, borrowing once isn't going to do the trick, because we've got two terms with 52 minutes in it. So we'll borrow twice. So I'm going to take 2 away from 180. That gives me 178 degrees. And 2 degrees is 120 minutes. And then we're going to subtract from this 47, 52. And again, 47, 52. Oops, 52. These should be degrees marks. So 120 minus 52 minus 52. Well, 52 and 52 is 104 from 120. That's 16 minutes. And then 178 minus 47 minus 47. Well, 47 and 47 is 94. 94 from 178. Let's see. Well, it's 6 below 100, so 78 plus 6. It's going to be about 84 degrees. So angle C, 84 degrees, 16 minutes. Oops, 16 minutes, not 16 seconds. Now, what else can we figure out about this triangle? Not too much. This is all scalable. We have to come over to this other triangle, this accessory triangle, where we know the length of one side. Notice we also know the angle in this vertex over here. Do we know any other angles? Well, there's no rule that's going to give us this angle up here at the top clearly, but right here we can use, again, rule of supplementary angles, and basically this angle is going to equal 180 degrees, 0 minutes, minus 47 degrees, 52 minutes. So again, the process is the same. We'll make this 60 minutes. We'll make this 179 over here. 8 minutes. 179 minus 47. Well, let's see. If it was 179 minus 49, it would be 130, but it's minus 47, so it's going to be 132. Let's kind of check our answer. 2 plus 7 gives you 9. Yep. 3 plus 4 gives you 7. Yep. Okay, so we've got it. So this angle here, 132 degrees, 8 minutes. Well, we can capture our third angle by the rule that we have 180 degrees in a triangle. So before I calculate this number here, I'm going to go ahead and clean up the drawing a little bit, redraw some of the stuff we know, and we will calculate that final angle. So here you can see I've cleaned up the drawing a little bit because our real interest was always with this accessory triangle, not actually with the triangle that forms the pyramid. Now the question is, what does angle C equal? Well, angle C equals 180 degrees, 0 minutes, minus 132 degrees, 8 minutes, minus 25 degrees, 15 minutes. So again, the process is the same. We do a borrow and carry operation. 179 degrees, 60 minutes, 132, 8 minutes, and 25 degrees, 15 minutes. So you think about 15 and 8, it's 23. 23 from 60 is 37 minutes. 172 minus 132, 179 minus 132 minus 25. Well, 132 and 25 is 137. Let's see, if it was 139, it'd be 40. So 42 degrees, 37 minutes. Okay, so angle C is 42 degrees, 37 minutes. Now, we have, if you notice, we know one of the sides and we know the opposing angles. So we can now set this up as a problem, a law of sines problem. So remember how this works is that the length of side C, which in this case is 500 feet, is proportional to the sine of angle C, which is 42 degrees, 37 minutes. And that proportion is equivalent to the length of side B as side B relates to the sine of angle B. 132, 8 minutes is as side A relates to the sine of angle A, which, let's see, angle A in this case is given as 25 degrees, 15 minutes. Now, we're going to have to arrive at some conclusion for this value, the sine of some number of degrees in minutes, and perhaps the easiest thing to do is to get this into a decimal number of degrees. So recall that to convert fractional degrees or degree minute seconds measurements into decimal degrees, basically you take the whole number of degrees and you add to it the number of minutes over 60. So if I pull up my calculator, the calculation becomes pretty simple. It's just 37 divided by 60 plus 42. So 37 divided by 60. So 37 minutes is about 62% of 1 degree, plus 42. And let's keep 3 decimal places. So this is equivalent to, if we come over here, we could write underneath here, it's equivalent to the sine of 42.617. Okay, so this isn't another mathematical function. I'm just writing it down here for a convenient place to store it. Is equal to the sine of 132 plus 132 degrees 8 minutes. So let's convert that. So again, it's 8 divided by 60. So 8 is about 13% of 60 plus the whole number of degrees, which in this case is 132. So the 132 degrees 8 minutes is equivalent to 132 point 133. And if we convert this 25/15, this one's actually kind of easy because 15 is just 1/4 of 60, so this becomes 25.25 degrees, right? And then the process of solving this is just algebraic rearrangement. So if we try to get b by itself, we're going to basically multiply both sides of this formula by the sine of this 132.133 degree angle. So let me rewrite this a little bit and we'll see what these numbers come out to be. So what you see here is just some looking numbers up and some algebraic rearrangement. I've just gone ahead and used the calculator to find sine values for each of the 3 angles. And I set up a proportion as we had in the last step, right? So 500, which is the length of side C, over the sine of angle C equals A over the sine of angle A. Then all I have to do is multiply both sides by this denominator to get A by itself, and this is what the formula starts to look like. So we can just solve this using the calculator now. So 0.427 times 500 divided by 0.385. Now if I think about it, 0.427 is bigger than 0.385, so I'm going to expect a number larger than 500. And I get, for side A, 554 feet, and then the 545 repeating. So let's write that down. This side here, 554.55 feet. And I can do the same thing for side B. So again, basically I'm going to end up taking the sine of angle B, which in this case, angle B, let's see, is that 132 degree angle. Sine of that's 0.742, so if I put that in here, 0.742 times 500 feet divided by 0.385. And if I look at this, this is going to be a number that's larger both than side A and side C. Well, that is logical, right? Because it's the side of the triangle opposite the largest angle. So if we punch this one up on the calculator,